Again, if you think, you don't have quite as much work to do. If a parabola only has one x-intercept, then that point is the vertex. Okay? Because if your parabola only has one x-intercept, it's because the parabola is either perched on the x-axis like this, or it's because the parabola is hanging from the x-axis like a bat. It's either perched like a bird or hanging like a bat in this case. And in either case, the x-intercept is going to be the vertex. Does that make sense? Mm-hmm. So if you get one x-intercept, that's your vertex. Now, if you didn't see this was a perfect square trinomial and solve it this way, you do it the way we did it yesterday. You get to the point where b squared minus 4ac equals 0, and then you go, oh, I've got one x-intercept, and that is my vertex. So that's how the other way you would work it.
Why do you draw it that way?
This way here? I'm sorry, this is an example of a different parabola. If you get a frowning parabola that happens to have one x-intercept, then you'll have a vertex up here. This is a different example. I'll try and do one of those, but let me erase that. Here's what I would expect on this parabola. I want you to label the points 0, 25. I want you to label the vertex, but to make sure you're drawing it right, if you get one intercept, I want 2 more points. And I want you to use A the way you did on the midterm. So I want you to go over 1, up 1 from the vertex, over 1, up 1 from the vertex in this case. Okay? And what will those 2 points be?
What do you mean?
What are the coordinates of those points?
4, 0.
Okay, 4, and then I went up 1, Jeremy.
Yeah, 4, 1.
4, 1, good. And then what will the other one be?
6, 1.
6, 1. And what's the equation of my axis of symmetry?
I didn't get that.
Axis of symmetry is a vertical line. The equation of a vertical line is always x equals
Never mind, I got it.
wherever it hits the x-axis. So what's this equation of my axis symmetry? That's going to be
5.
X equals 5. And I'm done. So my point for this example is, if you remember like perfect square trinomials, your work is easier. You don't have to pull out the quadratic formula. You can see what's going on sooner. Okay? Does that make sense?
Would you have to write it in an equation?
You mean like this?
See.
I'd like to see this work, yeah. I'd like to see how you know.
No, I would
Yes,
after
sir.
you're done.
Which
oh,
part?
wait, no, we'd have the same equation, right?
Yes.
Never mind now.
Yes. Okay, so this is the kind of graph I'd expect of this one. I need to do one somewhat quickly. I'm afraid of one where there's no intercepts in what I expect then. Okay, so you guys ready for that?
Yes.
Yes, no, maybe?
Absolutely.
Absolutely. Phil is absolutely ready. Is anyone else absolutely ready on this snowpocalyptic Friday?
No. Yes.
Okay.
It's not that
On the other
hard.
end of
Wednesday was the snowpocalypse. Today is snowpocalypse 2. The white. Okay. That's what a friend of mine says. We're making these into movies. This is snowpocalypse 2, the whitening. So everything's going to be buried under lots of white flames. No, I'm joking. In our joking imaginations, we are.
That's creative.
Okay, thank you. I don't know how to make this work.
So much bacon.
It's great. Y equals x squared.
Plus 3. No.
Plus 12x. Give me a sec.
Minus plus 37.
Plus 37. Okay, Amanda just got to a good point though. Okay. Which would be more useful for you guys if we're running out of time? Do you want me to work this out by the same steps we did yesterday? Actually, no, I'm going to work this out by the same steps we did yesterday, and then I'm going to show you a shortcut afterwards.
Can we do continuous square root?
We can. So hold that thought. But first, let's do it. Let's pretend we don't notice that this is close to a perfect square trinomial. And let's do one. Let's find our y-intercept.
But I have.
What is the y-intercept going to be?
37.
Can we say it as 0, 37?
Yeah.
Just to make sure I know that you know we're talking about a point on the y-axis.
How do you know that?
We put in 0 for x,
Oh.
and that's 0 squared plus 12 times 0.
And the vertex.
And then the vertex. So we do our x equals
No, when you
Negative
do
B
two,
over
negative b over 2a, which is negative 12 over 2 times 1, which is 6. Is that correct?
Negative 6.
Negative 6, thank you. Thank you very much. So then I know my axis of symmetry is x equals negative 6.
So would you have
Oh,
negative
this worked
30?
out really nice.
Okay, well hang on, now what we're going to do is, now we're going to say y equals negative 6 squared
No.
plus
Yeah,
12 times negative 6 plus 37. So y equals positive 36 minus 72 plus 37. So y equals 1. And so now I know my vertex is at the point negative 6, 1. We good so far?
No.
Please ask me questions, double check me, look for mistakes.
We're good.
We're good? Thank you. Okay. Now, from here,
Oh my god.
You're gonna do.
we go into the X-Intercepts, right? So I do b squared minus 4ac first to see if there are any. And this gives me 12 squared minus 4 times 1 times 37. And that is 144 minus 148, which is negative 4.
You want me to double check that?
Please.
So it has
What is negative 6, 1?
0.
The vertex. I apologize. I should have labeled that.
It
Okay?
has 0.
So this has no,
It's right.
okay, good. So this has no x-intercepts. Because it has no x-intercepts, and because I want your graphs to be lovely, absolutely gorgeous, then I want you to use A if there are no x-intercepts. So if there's no x-intercepts, you must use the A value to label 2 more points. You must use the A value to label 2 more points, okay? And you'll do it by going left 1 and right 1, and then up or down however many units A is, depending on whether A is positive, negative, etc. What is A in this case? I apologize.
1.
1. A is 1. Okay? I should have written that down.
It's really hot in here. Can we turn it down?
We can a little bit.
Thank you.
All right, so now we will record this. Okay, we'll record this parabola, and then I'll show you the shortcut.
I think I know what the shortcut is.
Okay, so let's see. My vertex is, you know what? I didn't pick these axes very well. My vertex is at negative 6, 1. My y-intercept is at 37. I'm thinking what I really need to see a lot of is quadrant 2.
Thanks.
Could have been worse. I could have graphed gone further. Okay? Now here, I've got to have a scale. It goes 5, 10. Hell, hold off a second on following me till we're sure I get this right, okay?
Yeah, right.
25, 30, 35. Okay. Okay, so 37 is going to be about there, and that's my y-intercept. So I got to look at the points and then pick my scale. And then I can pick a different scale in terms of size for the x-axis. 1, 2, 3, 4, 5, 6. 1's down there. So here's my point, negative 6, 1. Here's my axis of symmetry. Now you guys notice how 1 unit on the x-axis is bigger than 1 unit on the y-axis?
Why?
Because I chose to do that, meaning because I only had to go over 6 on the x, but I had to go up 37 on the y.
Wouldn't that change your axis? Wouldn't that change everything?
It only changes the look, but it doesn't change any numbers. And you don't have to do that. If you want to use enough graph paper, then you may do that. But if you want to, and you're careful, you can choose to have one represent a larger length on the x-axis and a shorter length on the